we're now going to use the substitution method to find definite integrals. And so I'm going to use a little technique that allows us to kind of simplify the work as we're using the fundamental theorem of calculus here. And I'm going to just show this by example. What I see here is I'm going to need substitution, because underneath the square root I have x squared plus 1, and then x on the outside is almost the derivative of x squared plus 1. So the derivative of x squared plus 1 is 2x, and so the x on the outside only differs by a constant. So I'm going to let my u equal x squared plus 1. So then my du would be equal to 2x dx. And so I'm going to substitute the x dx in for du. So I'm going to need to move that 1/2 to the other side. So 1/2 du is equal to x dx. Okay, so now I'm going to place things in here. So just wait on those limits for a second. So in for x squared plus 1, I get to put in u, so I get the square root of u. And then in for the x dx, I put in 1/2 du. And so that would be my substitution. But now these limits, it's no longer going to be 0 to 3, because I'm doing it with respect to u. So I need to find out what u is when x is equal to 0. So I'm going to plug 0 in to this formula here. Okay, so if I plug in 0, I get 1. So my new limit is 1. And then plug 3 into here. This will be 10. 3 squared plus 1 is 10. So then I get a 10 up here. So I'm integrating with respect to x from 0 to 3, but with respect to u, it's from 1 to 10. Okay, so now I'll pull out the 1/2, and then 1 to 10, and then that's u to the 1/2 du. And so now I just do this integral. So this would be u to the 3/2 over 3/2 from 1 to 10. And so now I can plug in both these limits into that. And so when I do that, I'm going to get 2/3 square root of 10. That'll be for the 10 minus 2/3 the square root of 1. And so the exact value would be, I could write it 2 square root of 10 over 3 minus 2/3. Or I could even write it 2 square root of 10 minus 2 over 3. Or I could write 2/3 square root of 10 minus 1. However you write it, okay? That's going to be the exact value, and you could get a decimal approximation by putting it in your calculator. So the important thing I'm wanting to show you is when you use the substitution method, you're substituting things in for u. So you're substituting u in whenever you have this expression, and you're substituting the du in correctly according to this, and then you got to substitute these limits here by actually placing them into u. Okay, when you use the substitution method, that's the important thing. So now let's try this one. So I got from 1 to 4, and I got I got e of x squared over x squared. So if I remember, the derivative of x squared is like 1 over x squared. It's 1/2 1 over x squared. Okay, so I'm going to let my u be the x squared. So I could rewrite this like this: 1 to the 4th e to the square root of x, 1 over square root of x dx. And then I'm going to let my u be the square root of x, and then my du would be 1/2 times 1 over the square root of x dx. And so I move the 1/2 to the other side, and I get what I need for my substitution, because that's what I need here. And so now I'm going to plug u in for the square root of x. I'm going to plug 2du in for this, but then I also have to update these limits by plugging these into here, because these are for x, and so I need them for u. So now this is going to be the following. It'll be e of u, and then I have a 2du in for all of this, and then plugging in 1 into here, I get 1. Square root of 1 is 1. Plugging 4 into here, I get 2. Square root of 4 is 2. So I get 1 to 2 of this. So then I could write that 2 integral 1 to 2 of eu du. And then the antiderivative of e to the u is just e to the u. So I get 2 e to the u from 1 to 2. And so this would be 2e squared minus, so that's plugging in the 2 and now plugging in the 1. 2e to the first. And so I don't know how you want to write it. This is kind of the exact value, or I could pull the 2 out and just have e squared minus e. Something like that. And this, of course, is a constant. So you could plug it in a calculator and get a number for that. Okay, again, you got to update these limits into these limits by plugging the limits into here first, okay? So let's try one more here. One involving some trig functions. But what I see here is that and it would be easier to see if I wrote it like this 0 to 2 pi over 3. And if I wrote this as like 1 over cosine x quantity squared sine x d of x. So now I can see I'm plugging in the cosine into here, and then the derivative of cosine is the opposite of sine, which is almost the sine x, right? So I can let my u equal cosine x. So then my du would equal the opposite of sine x dx. So then I can move the negative sign to the other side. Negative du is equal to sine x dx. So I can plug my u into there. I can plug in my the sine x dx. I can put in negative du for that, and but then I have to put both of these limits into the cosine of x. So then updating everything. So I'm going to take that negative and put it on the outside, and then I'm going to get 1 over u squared, and then this will just be the du there. So I get all of this, but now my limits, if I put in 0 into this, cosine of 0 is 1, and then if I put in 2 pi over 3 into that, then what I'm going to get here, cosine of 2 pi over 3, we remember, 2 pi over 3 is like up here, and that would give me a cosine of a negative 1/2. So this is like a negative 1/2. Okay, and so and that's weird because this isn't going in order. It's okay, you can still integrate it by plugging things in. Another thing you can do is this is a minus sign, and I haven't shown any of these. Oh, I should show. You know what? I'm going to try to remember to show you some of these when I'm done. But I can flip that over if I want to and get rid of the negative sign, and I would get negative 1/2 to 1 like that. And I'll show you the properties that give you that in a second. So then this would just be like u to the negative 2 du. And then I can plug, oops, sorry. I can actually take the antiderivative now, and so I would get u n plus 1 would just be negative 1 over negative 1. and then this would be negative 1/2 to 1, and so this, I could rewrite that as negative 1 over u from negative 1/2 to 1. So now let me just plug these into here. Negative 1 over 1 minus a negative 1 over negative 1/2. A lot of negative. It would have been, yeah, it would have been even more with the other negative. But that's okay. So we're going to plow through this. And so this would just be negative 1. The negative 1/2 would flip over, and this would become positive 2. So negative 1 minus 2 is what that would be. And so negative 1 plus a negative 2 is minus 3. So it looks like that's what I would get. Okay, so I wanted to show you a couple, well, let me just show you that one here. So you can, we know that you can split up the thing over a sum and difference, but there's one that says this, is that the opposite a to b f of x dx is equal to b to a f of x dx. So in other words, you can flip these two signs by putting a negative sign out front. Okay, and it makes sense with the fundamental theorem here. You know, you could almost show this. If you had this f of x dx, this would equal the opposite of f prime of b minus f prime of a, right? And then that, distribute that and commute, you get f of a minus f of b, and then that would be equal to the b would be the lower limit, the a would be the upper limit, f of x d of x. So there you go, you just showed it there. So you can, if you have a negative out front and you want to flip the sign, you can do that, or flip the limits. Okay, so there you go. That's just using substitution then, along with the fundamental theorem. You just got to make sure to update the limits as you are doing the substitutions, as you're changing from dx to du.